Good afternoon or evening, students. This is your first video over basic set concepts, and it's section 2.1 in your textbook. We're going to do 2 or 3 videos on this section and 2 or 3 on the next section, and you know why I'm redoing these. So I told you today in class. So let's take a look first at the vocabulary for this section and what we need to know to be able to move ahead. So the first bit of vocabulary is the word set. So what is a set? A set is just a collection of things. That collection then it can be a collection of anything. So I can have a set of animals from North America, so it could be deer and alligators and bears, or I could have a collection of students in my prob and stat class at 8:35 in the morning, etc. So there are lots of things that could be a set. Number 2 then is, what are elements? Well, elements are the things that are in the set. So if you wish, there are the things. Okay? And that's pretty important. Sometimes we call elements members of a set. And then finally, the third probably beginning term is the term well-defined. So what is well-defined in set language? Well-defined means that your description of your set points to what the elements are exactly. So well-defined really means a good description, and it's a really good description. And let me give you an example of something that's not as well defined as you think it is. So I want you to write down on your sheet of paper the set of presidents. So pause the video and think about that. So now that you've hit play again, what did you write for the set of presidents? Did you put Washington and Lincoln and Obama and Bush? Did you write down U.S. presidents? Well, that's probably what most people would do who lived in America and you wanted to write down the list of presidents. But many other countries in the world have presidents as well. So you could have put down Vladimir Putin, who's the president of Russia. You could have put down the president of South Africa if you knew it, etc., etc., and you would have been correct. See, our description just said, what's the list of presidents? However, if we really wanted U.S. presidents, we would say, write down our definition, our well-defined definition would be, write down the list of United States presidents. Or write down the list of United States presidents since 1960, all right, which would be Kennedy, Johnson, Nixon, Ford, Reagan, Carter, Bush 1, Clinton, Bush 2, Obama. And so that would be a well-defined set, and we would know what things, what members were actually in that set. Okay? So, 3 other things, and this is what's going to concern your assignment in terms of the work you do. And those 3 other things are going to be the word description, the roster method, and set builder notation. So what's a word description? Well, that's just what I did when I defined U.S. presidents. It's a word description. What's the roster method? Well, when I asked you to make a list of presidents, you were actually writing down names of presidents, and that's a roster. And when you do a roster and you list them, you surround them by braces and separate each element by commas. And then what's set builder notation? Set builder notation is a special mathematical way to write things, and it's a way to tell you what the list is, but also write it down in words efficiently. And sometimes you can use math notation. For instance, and before I do the example, I want to tell you about what this means. This means is an element of. And that's very important for set builder notation. So let's go to the next slide and I'll show you a set builder example. So what I want to do is I want to list the U.S. presidents since 1961, and I want to do set builder notation. So to start off with set builder notation, I start off with a brace like that. And then I can say the set of all presidents. And so what I'm talking about is all the presidents possible, not just U.S. presidents, but all presidents of any country for all time. So I can write something like this, the set of all presidents, and then I put a straight line. And that straight line means such that. So the set of all presidents such that it is a president in USA since 1961. And then I put a closed brace like that. So that's a very typical way to write set builder notation. It's a way to do it in words in such a way that you can list things in word notation and use notation to kind of substitute for words, so you're not writing out this huge long sentence. So let me show you how it works in some sense in mathematics. Suppose I say the set of all x, which represent any number, the set of all x such that 2x plus 1 equals 5. Well, what's that set contain? Well, I want the set of all x's that are solutions to this equation. So I can now do it as a roster. I can do 2x plus 1 equals 5, 2x equals 4, subtracting 1 from both sides, x equals 2, and now by a roster method where I just list the elements, I just put a 2 down. And so these two sets are equivalent, all right? And you want to remember that idea, so let's call that other vocabulary, equivalent, which means the two sets, set A is equal to set B. They're exactly the same set. So one other thing I want to say, notice I used capital letters when I was illustrating a set. And that's conventional practice and one of the things you want to do. Okay, let's pause for a second and then we're going to look at some example problems for your homework. So here's our first example. What we'd like to do is we'd like to decide, is a set well defined or not? And so I have two sets here. The first one is the collection of U.S. presidents. And the second one is the collection of the 5 best U.S. presidents. So what would you say? The collection of U.S. presidents. Well, I could do that. I'm going to list them. Washington, Adams, Jefferson, Madison, Monroe, and if I had enough time I would list all 44 all the way up to the last one, which was Obama. Alright, so I could list the whole collection of U.S. presidents. So that is, the answer here is yes, this is well defined. All right? So now let's come to the second question. It says the collection of the 5 best U.S. presidents. Well, in my opinion, the 5 best are Washington, Lincoln, I would say, let me just use the mountain in South Dakota, and so I'll put Jefferson, and I'll put Roosevelt, Teddy Roosevelt, actually. So Teddy Roosevelt. And then I need a 5th one, so I put Reagan. All right? Now, look at that. Well, who'd you list? Well, you might have listed Washington and Lincoln and Obama and Clinton and Kennedy. And so all of a sudden you can see that this set is not well defined. What's the problem? It has a qualifier, the word best, that makes it opinion-based rather than fact-based. And that's really the difference between what is well-defined and what is not well-defined. Okay, in the next example, you're supposed to write a word description of each set. So I have a set A here, and I want you to write a word description of that set. So pause and take a second and try it. Okay, now, what'd you write? Did some of you write set A is the numbers 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. to 20? Did some of you write set A is the numbers that start with 6 and end with 20? Did some of you say set A is the positive integers starting with 6 and ending with 20? Or did some of you get clever mathematically and say set A is the numbers 6 less than or equal? Oh, that's just, I was trying to get fancy. But as you can see, you can say A is, I apologize, that happens. That's why videos are fun. Anyway, you could say set A is the numbers starting with 6 all the way through 20. And by the way, do you know what the 3 dots mean? It's called an ellipsis, and it just means continuing on. Okay? So we know it's all the numbers between 6 and 20, including 6 and 20. So any one of those descriptions would be perfectly acceptable in words. Okay? So the next one is we want to writing out sets in a roster method where you actually list them. And by roster method, you're looking at a problem. For instance, the set of natural numbers less than 4. So what is that? Well, number one, you got to know what a natural number is, so you might have to look it up in case you've forgotten. But the natural numbers are the numbers 1, 2, 3, 4, 5, on and on forever. So we want the set of natural numbers less than 4. So I know what that is. I can say set A is equal, and here's my roster. And so I can list 1, 2, 3, and that would be the set of natural numbers less than 4. Notice it doesn't include 4 because it doesn't say less than or equal to 4. Another way to do this is you could have been given this in set builder notation, and it would have looked like this. And you would have had something like this that said the set of all x such that x is an element of the natural numbers and x is less than 4. Well, by roster method, that would have been the numbers 1, 2, 3, natural numbers, less than 4. And that would have been exactly the same set. Okay? And that's your homework. So your homework today is going to be starting on page 55. And I want you to do problems 2 through 30 even. And you can work on that before you come to class, or this is what we're going to do in class. I just want you to know that. Actually, I apologize. 2 through 32 even. Okay, we'll talk to you later. Bye.